बाकी लोग कहाँ रह गए, ज्वाइन नहीं किए अभी तक।
चलेगा भाई।
So, very good morning once again to all of you. Can you see my screen? Or you can't?
So we can.
Fine. So, Arey Baba. So we will let's start talking. Remember, I told you. Yeah, somebody was asking that whether I'm on leave or not. So I'm traveling, but I could manage to get the network, and I could manage to give this lecture. So let's have it. Any which way, this lecture, what we had planned was uh, some sort of demonstration, because I've been teaching many topics so far and we have not demonstrated quite a few topics. So last few classes we have spoke about frequency domain analysis and concept of high frequency, low frequency, etc., etc. We were talking about the noise in the image, and then different types of noise analysis, etc. So I think it's a good time for us to look into some of the demonstrations of these concepts. Okay, the feed is available now online, so if anyone is joining late, please request that person to get on the YouTube and watch it. And I'm keeping that feed open in front of me, so if you want to message me, you can message me there also. The messages would be available to me. The link is available in the box. So yeah. So today I will show you some of the things in Fiji or image J. Remember that some of these things I have already talked about, but I never showed it to you. So let's go ahead. I will open some of the images. Basically I am looking at an image. Let's look at the frequency domain. So two images I'm going to work with. One is this, which looks very straightforward. Can you all see that this is a noisy image? What is the nature of the noise in this image? Can you tell me? Can you discuss that with me for a while? Anyone?
So it's periodic noise.
How do you know it is periodic?
So it has a certain kind of a trend in the horizontal direction. That's what I can
Yeah, so
say.
the
Looking at.
direction of periodicity is it horizontal or vertical?
Vertical.
Yeah, that's a very important thing you must realize that the direction of periodicity is not horizontal, because if you take any horizontal line, then all coordinates have same value. This periodicity is vertical. What is the low frequency in this and what is high frequency?
So the background is low frequency.
And what is high frequency?
The facial structure.
Anyone else would like to comment on it?
The spectacles, maybe.
What is spectacles, low or high?
So high frequency.
In this case, remember the concept that we had discussed earlier, that was smaller the object, generally higher the frequency. But that was for random images, like random objects in the images. In this image, you will find that there's a very distinct periodic object is there. Those periodic objects are what? So those periodic objects, if you see it carefully, then those periodic objects are these lines. These lines are very distinctly present. So it's a very specific single frequency noise. Do you see that?
Yes, sir.
Yeah.
Yes, sir.
Now obviously the facial features are broad. Don't repeat that often. They are low frequency. There is something in the shirt. Can you see vertical lines? They could be another high frequency thing. So what is the best strategy to remove this kind of noise?
So FFT.
Yeah, so the best strategy is to use frequency domain analysis. So ImageJ offers us to do it quickly. So all I can do is that I will go to analysis or what process, go to FFT, and I will press on FFT. There are other options also. I strongly recommend to go through each, read about them and see it. Now here, this is the FFT. Now in FFT, where, can you tell me where will the person's face be there in FFT, and where will be these noise lines? Can you tell me?
So the person's face must be closer to the lower frequency sites.
Good. Where will be in this rectangle? Where do you guess could be the person's face? I'm again asking, it's a guess. FFT, by looking at FFT, you cannot have a correlation. But if you know the science behind FFT, you might find some correlation. And that many a time that guess will be a good guess. So can you tell me? Can you guess?
So the center one, maybe.
That's right. Face most likely is a very low frequency. So you can go, it will go at the center. Now these are horizontal and they are periodic in vertical directions, correct? So where will these horizontal, like periodic frequencies will go? So these are vertical periodicity, so they will go on vertical axis. So most likely this is one, is this is a frequency, strong frequency present, this is a spot. So this spot is going to be this one, okay? This is a, remember this is a harmonic of it, this is another harmonic. So these are the higher frequencies. This is not an harmonic, but this is something else that might be there, something which is still higher frequent than these lines. And remember this FFT is always plotted symmetric, so you will get on this side also. Is this clear to everyone? Let us remove the center and see what do we get. So I can go to again process FFT and I can say inverse FFT. Do you see this? Is it visible?
Yes, sir.
Yeah. So now you see what happened. You can see those lines are there, but the face and background, they are very strongly suppressed. Okay. In fact, if I become more adventurous and take this completely down, then the entire background is suppressed. White colors are suppressed. That is why you will find that those lines are visible. But since white color is gone, the background white, only the lines remaining. Some caricature is there which is also remaining, but any brightness in the background is almost lost. Okay, so let's repeat this to remove the lines. I want to remove noise, so let's see how best we can do it. So this time I'm going to cut the high frequency part as sharply as possible. Okay, and then I go to process, I can go to inverse FFT. Do you see any difference?
Yes, sir.
You will see it's a fantastic change. The entire facial area, those periodic noise is almost gone, and all you have left with the human face, which is fairly acceptable, isn't it? If you just zoom in and see, you will find the difference. Correct?
Yes, sir.
It is fairly acceptable. Can we make it even better? Let me remove some harmonics also and see what change that brings. So I had suggested you people to do it, but I don't know, I did not get any favorable answer from you people. So I thought I should do it and show it to you. Might have gone slightly more better. You can see that removal of first harmonic had a very strong impact, but removal of subsequent harmonic does not have that strong impact. Okay, what happens if I apply something called as a low pass? I keep only this and remove everything else. Keep the center part and I remove everything else. Let me see how can I do it. Bit challenging. I mean, there are options, although since I don't use much, I might have lost many. I'll just do a crude way. So I can always delete whatever components I don't need, just keeping the center and removing everything else. Ideally, there is a method available by which you can just select the center and delete everything else. Now I make it an inverse F50. Can you see the difference now? So you can see that image has become little blurred, but those lines have gone, but you have some more ringing effect, like shoulder line, multiple lines have appeared. Some more noise, different kind of noise has come in. So your correct answer will be somewhere in the middle. What we did earlier and what we did now, somewhere in the middle you will get a perfect answer. So it's a trial and error method that you have to work on. So this is one example for today. I'll go to the next one. This is an image which I'm opening. Can you tell me where is the noise? What are the noise here?
So the diagonally alternative white and black lines.
Yeah. The diagonal is a noise. And then these thin lines are also noise, right? Periodic noise. Now tell me, what is a high frequency, what is low frequency? Any comment on that? Because that way this you will find this is a bit challenging.
So the cycles maybe are the high frequency components.
Cycles are not high frequency. Remember, the smaller the objects, higher the frequency. Don't you see anything else is smaller than cycle? Do you?
So the
See, can you see these
so the
small?
noise component.
Can you see this small thin grid patterns? Thin grid patterns.
Yes, sir.
That isn't that a higher? Won't that be a higher frequency? That will
Yes.
be. No?
Yes, sir.
But this broad pattern, this slanting pattern, this is also noise, periodic noise. Is this a high frequency periodic noise or a low frequency?
Low frequency.
Now compare the periodicity of this noise with the periodicity of windows. So which is higher frequency? Periodicity of windows are placed at a higher frequency, or this diagonal noise is placed on at higher frequencies?
The diagonal.
So the,
I'm talking about higher frequencies, remember.
so the windows.
windows are smaller, na? You see the periodicity from here to here. This gap is very wide, while this gap is very small. Windows are at a higher. Here is a case where you have noise at a very high frequency, these thin lines. You have a noise at a very low frequency, these broad diagonal lines. But your object is in the middle frequency. Do you see that? So by looking at the image, you should be able to analyze it. That's the whole idea of showing this. Every image is different, so analysis is different. You need to sit with the image, look at it, try to figure it out what kind of correction things will be applied to it. So let's take the FFT and figure out what is there in the FFT. So this is my FFT. Where will be the building in the FFT? Where are these diagonal lines in the FFT? So remember, they are very large. So they will go towards the middle of the low frequency component. They will go dead in the middle. If you observe the middles carefully, remember the diagonal lines are there. So you will get, if the diagonal lines are this way, the periodicity is this way. Can you see my screen? So if the lines are from northwest to southeast, their periodicity would be from southwest to northeast. That is how the periodicity will happen. So you will get a periodicity spectrum in this diagonal. So this is the case where you get. You can zoom it further and observe it. So here what is happening is that most likely chances that this is your periodic noise. This is your periodic noise. So can you eliminate it? So I remove this and I remove this. Only two spots I am removing. And I go to process, I go to FFT, I go to inverse FFT. Oh Lord, what has happened? कुछ गड़बड़ हो गया. I think we have deleted, we went too close and we have deleted the building altogether. Isn't it?
Yes, sir.
Yes, sir.
Yeah, let's see. As I said, it's a guesswork. So you need to figure out. Let me take FFT again because it does not have an undo option. But it has to be along the diagonal. What is happening? Let me remove these two dots and see what is there. ये वाला हमने ये वाला डिलीट किया था. Let me now delete this and this. Now I go to process FFT IFFT and see. Something else has happened. No, but those diagonal lines are present. Building has also appeared. Okay. I don't know what is happening here. Let us take one more attempt. what will happen if I delete the center? Building will vanish now. No, it's not working out, man. What do you do? One more try. These are the random images I picked up from the internet for to demonstrate. So let's go somewhere else. Let's remove the high frequency. So just get rid of something here, something here, something here, something here. ये हाई फ्रीक्वेंसीज को एलिमिनेट कर दो, फिर देखते हैं हमको क्या मिलता है. Take an inverse FFT. Still the same thing, something stupid, similar. Process FFT. There has to be a diagonal noise that corresponds to. Let us be little much thoughtful. So there has to be this diagonal, there has to be a noise that corresponds to this variation, which has to be a sufficiently low frequency noise, and there should be thin horizontal and vertical noise. So दो तरह की noise तो होनी चाहिए. इसको एक एलिमिनेट करते हैं, एक इसको एलिमिनेट करते हैं, and I'm unable to figure out कि वो जो low frequency noise along the diagonal है वो कैसे जाएगी. Anyway, I will give this image to you people and you people work on it, and if anyone gets great results, share it with me. Would that be okay?
Yes, sir.
Aim is to remove the periodic noises, vertical or thin lines and these broad lines, and get the building structure clear. That is the aim. So I'll give it to you in the in your group. Try to work it out today, tomorrow, and let us go to. And if I will also work out, if I get a solution, I will share. The method remains largely the same. Let me take another image, which is of a different type. So as I said, last class or last two classes we discussed that this is a image with a random noise. Can you see the train image? Now here the noise is very randomized, no periodicity. So if it is not periodic, if it's random, then obviously chances is that there are a lot of frequencies present, and all these will fall in the higher frequency. Low frequency is train, high frequencies are all these dots. So if you take an FFT, all the high frequency components will be in the higher order, away from the center. So I'm going to show you. Look at this now. You will find very interestingly that you will find very interestingly that there are no specific dots. Why aren't there specific dots unlike in the previous case? Because there's no designed frequency. Do you notice that? There's no specific frequency. So all you can do is just delete or cut short the higher frequencies. तो इधर का निकाल दो, हायर फ्रीक्वेंसीज निकाल दो. अभी कितना क्लोज जाना है सेंटर के, दिस विल बी अ ट्रायल एंड एरर. But remove it and then you find an inverse FFT. So you will find that lot of train noise, train data has also gone. Okay, that means you are too close to the center and you are losing lot of data on train as well. You don't want to do that. So just stay away from the center. So go to process, take take FFT, but this time you just let only higher frequencies vanish. So I'm not going too close to the center. Only trial and error will give you this experience. The more you work, more easy for you to figure out how the process works. You can now see that the train is bit more sharply defined than in the previous case, but you can easily see that these lines have gone. Okay, so still there is some issue. We will take one more attempt to process this before we move on to the next demonstration. So FFT. Now I am going to do a very drastic change. So all I am going to do is I'm going to delete everything which is there in that, because all these dots which are up here periphery, they are also showing noise. So I'm going to delete everything in the high noise domain, just retaining things in the middle. And my litmus test is that I should get these rods clearly removing the noise, because the rods and the noise, they are of the same size order. Noise will be a bit smaller, so finding the exact cutoff is a challenge. So you should be able to find the exact cutoff. And again I said that you will get to know by trial and error. Let's see what is the result. Yeah, is it better?
Yes, sir.
I think it is better than earlier results, right? We have reduced noise quite a bit, but these rods are not lost. Train structure is not lost. That means I still have the margins of coming close to the center. So let me do that. And this is how the trial and error works. Remember, my litmus test will be I should not eliminate those rods. Yeah, now I have a third instance. This is original, this is second. Compare original with the first attempt. First attempt, right side, definitely better than the first original, right? Now compare the right hand side with the third one. Is it better?
Yes, sir.
Yes,
I
sir.
would say slightly better, correct? and I can still
Yes,
see
sir.
these rods and lines clear. So I still have the opportunity to go closer, right? Let us chop a bit more higher frequencies from all sides. In fact, those most of those rods and lines are vertical and horizontal. So I can chop some of these corners because there is no data in the corner. Remember, it's a random noise. Random noise will have periodicity in the corner directions also. So I removed all these and take one more attempt at inverse FFT. Yeah. Now let me make it smaller so that we can see, compare. So this is the last attempt. This is first attempt. This is second attempt. Unfortunately, I make it too small. Yeah, can you see that?
Yes, sir.
I think this is from, let me put them in order so that we can compare them. I think this is the order. This is original. Okay, then this is the next, slightly better. Then this is next, even better. And you can see that, compare this with your original. And you can see the distance by which you have come. Okay, you still have some margins and you can work on it. Okay, so just to demonstrate that part further, as I said, random noise generally in your FFT will spread in all directions. So I can cut it in the corners because most of the train image is along the horizontal and vertical. Train's lines structures are horizontal and vertical. So I'll take and process FFT, inverse FFT. Now look at it. I think it's slightly more better, but you can see that some loss of data has happened, right? It was more adventurous. So I'll stop this one at this stage, but I will take the original image. Remember that this is low pass filtering. In this we have removed all the high frequency component and we have retained only the low frequency component. Do you see that?
Yes, sir.
Yeah. Now I take this image and I will apply a Gaussian, let us say, or Gaussian blur, or I convolve with a normal blur filter. No, this is not a blur. I convolve with a Gaussian blur, let's say. So blurring is, again, as we all know, I will put a 5x5 Gaussian blur, and you can see that it produces the blurring effect. Okay, so this, applying a blur filter is equivalent to say that it is a low pass filter. Okay, so this is the one part of the demonstration. I think I will share these images with you people so that you can work on them and figure out how to reduce noise. 3 of them. Next class I'm going to do some more demonstrations on what we discussed in the last class, that is about the image what you call noise parameters, how to calculate noise, how to take a sample of the image, get the noise, and then work on it. Okay, so with this we end at least the live streaming, and then we can